At the conclusion of the previous video on rates of change, we kind of hit this idea of the slope of a tangent line as that instantaneous rate of change. And we kind of came up at the very end with, if you know the slope and know the point that it is on the curve, you can come up with something that is called a tangent line. And you can get the equation of that. Now, we're going to go ahead and try to keep this in point slope form of a line. So just a quick reminder on what that form of a line looks like. Y minus y1 is equal to m times the quantity x minus x1. And more times than not, in a calculus context, you can just leave it right there. Now, a tangent line can be useful for estimating function values close to the point in question, but just as an estimate. Obviously, the original function might work a little bit better. Okay. Now, a normal line, on the other hand, is just like a tangent line, but it is perpendicular to the tangent line. So coming up the equation of a normal line shouldn't be just more challenging than that of a tangent, because the slope of a normal is just the opposite reciprocal of the tangent line. Well, lines that are perpendicular have opposite reciprocals. Okay, so the normal line to the curve is the line perpendicular, and the slope of the normal line is the opposite reciprocal of the slope of the tangent line. Okay, so what does that look like for our problem? Well, let's explore that here. Find the slope of the curve at the point x is equal to -1. So let's go ahead and do that first. So we need to bust out our limit definition here, because as of this moment in the class, we don't have any other choice. We don't have any other tool. And our a value is -1. Okay, so that's the idea. Let's see what happens when we plop this in. Now remember, when I put this in, I have to also add 2 in addition to squaring off whatever the expression is. So this is the limit as h approaches 0 of -1 plus h quantity squared plus 2. And I have to emphasize that because we have to add that 2 on as part of the fraction, or function rather, function. Okay? Now let's do minus f of 1, well, or -1 rather. So f of -1 is going to prove to be 3, and this is all over h. Okay, so I guess once again it looks like I need to FOIL this out and hope something good happens. So it's 1 minus 2h plus h squared plus 2 minus 3 all over h. Now, lucky for us, we are going to get all those constant terms to drop out, because 1 plus 2 minus 3, that's going to wipe all of that out and make it 0. So we get -2h plus h squared all over h, and just like the previous problem, we can factor out an h to get it to drop, and I get -2 plus h. And then when I sub in 0 for h, because now I'm finally safe to do so, and remember, keep that limit notation going all along, okay, that's going to give me -2. Okay, now I need to find the equation of the tangent line. This right here, this is the slope of the tangent line. Okay, and I need a point. Well, I've got my x-coordinate from up here, and my point is going to be -1, and well, how would I get the y-coordinate? Oh, that's right, I put it into the original function. So that's going to end up being 3, and the observant in the room will note that f of -1 is also 3, so I could have stolen it from there if I'd had to, if I didn't want to work so hard. And now I'm going to put this into point-slope form. Okay, so here's the y1, here's the x1, and here's the m. So y minus 3 is equal to negative 2 times the quantity. Okay, x minus negative 1 is x plus 1. I'm going to go ahead and leave it right there. I'm not going to push my luck any further. I just don't feel like doing any more algebra. You get the idea. Okay, now if I want to find the equation of the normal line, the good news is I don't have to do anything other than change the slope to the opposite reciprocal. So I keep everything else the same except the slope. It's now 1/2 because the opposite reciprocal of negative 2 is 1/2. Okay, one more page here. As I zoom in on this, we need to note that all of these things mean the same thing. The slope of y is equal to f of x at x is equal to a. The slope of the tangent line. The instantaneous rate of change. Okay, well, perhaps I should have not written in rate of change. A little overzealous there once again. Okay, the instantaneous rate of change of f of x with respect to x at x is equal to a. Okay, another thing, the limit as h approaches 0 of f of a plus h minus f of a all over h. That's also the same thing. And the expression that we just wrote in, that quotient, f of a plus h minus f of a all over h, that is called the difference quotient. That may have been a vocab term you heard in pre-calc. It's not something I tend to emphasize all that much, but it is something that comes up from time to time, so it helps to be able to be ready to know what that is when we see it. Okay, so all of these are the same thing. Why do we go through this? Because the AP test loves to tell you the same thing in about 5 different ways. And look, we've got 5 different ways here of discussing slope of a curve, either explicitly or as the slope of the tangent line or as an instantaneous rate of change or by a formula or maybe through a difference quotient here. All of those things come to mind right away. Okay, let's take a look at a quick example here. Okay, find the slope of that curve at some point A. Limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, now I don't have a specific numerical value, so maybe my answer won't be in terms of a number at the end. It might be in terms of a. So let's see if we can figure something out here on this. This is going to be the limit as h approaches 0. Okay, now very key important thing here. When I put this into this function, I'm going to get 1 over a plus h. And when I put a into this function, I'm going to get 1 over a. And that's all divided by h. Ugh. Looks like we need an LCD here. So what is that LCD for this particular problem? Well, the LCD is a times the quantity a plus h. So I'm going to multiply in the parts that are missing here and see what we get. So it's a over a times a plus h minus a plus h over a times a plus h, and this is all over h. Okay, still can't take the limit because, undefinable. So let's gather the like terms up top, and I also note that I need to distribute this negative to that entire quantity. So I'm going to get negative h over a times a plus h all over h. All right. Sneaky trick number 9462. Negative h over a times a plus h. Multiply by the reciprocal, and then everybody say goodbye to h. Goodbye, h. Thanks for playing. Limit as h approaches 0. Negative 1 over a times a plus h. Now, we are finally safe to plug in 0. And now that we're able to do that, we get negative 1 over a squared. Okay, good. So what's the slope, or where does the slope equal negative 1/4? Okay, well, if this expression right here is the slope, then I just set it equal to negative 1/4, and maybe we can solve for those values. Okay. All right, I don't think it's going to take too much to come up with a being plus or minus 2, because the negatives will wash out, you cross multiply, you square root, sing along with me, you know the words. You're going to get plus and minus 2. So those are the x values at which the slope is negative 1/4. Okay, a little cranky on the math there, but not too bad. All right, last example here. Find the instantaneous rate of change for this function in terms of time. I apologize for the noise in the background. Sorry about that. The poor dog was having a bad dream. I hate it when that happens. Poor guy. Okay, so to find this instantaneous rate of change for what's called a position function. Now, a position function is a function that tells me where something is relative to time. And we'll talk more about that in unit number 3 in our class. So the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, well now we have at least a t value here, which is kind of nice. So that's the setup, and I have to plug in 2 plus h everywhere I see a t. So, gosh, it looks like the algebra is going to get a little unpleasant here. So 2 times 2 plus h to the second power minus 1. And then when I plug in 2 into here, let's see, 2 squared is 4, times another 2 is 8. Looks like I end up with 7. Okay, bear with me. Let's do that. There we go. All over h. Okay. Once again, a little FOIL. And let's see what we can find out here. So this is going to be 2 times 4 plus 4h plus h squared minus 7. Something went amiss here. Where could I have gone wrong? Ew, I forgot to take away 1. See, I knew I'd make a boo-boo. All right, good thing I caught it. Should be a minus 1 there and a minus 1 there. And why is that? Because that's part of the function. I just simply forgot to write it down. And you know what? That's a common mistake that you've got to watch out for when you're doing these problems. Okay? We are almost through this. I promise. I swear. So 8 plus 8h plus 2h squared minus 1 minus 7 all over h. Okay, it looks like the numbers will cancel out, and I'm going to get 8, and so will a power of h, so 8 plus 2h, and then I think we're going to finally get an instantaneous rate of change of 8. Okay, that's what it ends up being. So there is our discussion on the rates of change, tangent lines, and normal lines.